This video is here to get you comfortable with what happens in Investigation 4A in our physics course. We've been learning about conservation laws up until now. We've learned about momentum and energy conservation. And now we're going to take a little bit deeper dig into the idea of work and how we do work on a system. So I have here this strange looking system. This is just our standard normal stand. I have a chunk of weights hanging down on the bottom, a piece of wood. And you'll notice some pulleys down at the bottom and some additional pulleys up at the top. There are these red strings in between, and those are there just to hold the thing up so it doesn't end up on the floor. The idea is that we are learning about devices that allow us to do work, but they make it easier. And this is one of those devices. This is called a pulley system, and a pulley system is made to make work easier. Now that's going to be a little confusing, and one of our first goals is to figure out what we mean by easier. Now you know the way we measure work is force times distance. This, of course, is a spring scale, and it allows you to measure the amount of force you apply when you pull just by reading the values on the scale. You don't have to be able to read them, but they're right here, and the further you pull, the bigger the number is. But the idea is if I take this spring scale, I can lift up this load down below. And if I look at this scale right here, it tells me that load weighs 10 newtons, or it takes a force of 10 newtons to lift. So effectively, if I'm going to lift that thing up, it takes 10 newtons of force. Now, if I'm going to do it with something that makes it easier, I'm hoping that easier might mean, well, it doesn't take 10 newtons of force. So here I have a chunk of string. I'm going to loop it up and over the top, over one of these pulleys, and then I'm going to clip the string onto the bottom. And now my hope is that to lift up the block down at the bottom, I can do it with less than 10 newtons of force, or at least that's what I'm going to try. So now if I grab onto the string and I give it a pull, hey, I can still lift it up, and in fact it still takes 10 newtons of force. In fact, it might even take a tiny bit more than 10, but maybe in some way it's easier because now I'm pulling down instead of pulling up. Strange. You notice there's one yellow string lifting this thing up. I can measure how much I need to pull right here with this spring scale. That's called the input force. And I can measure how much this system lifts on the object. That's called the output force. But that doesn't seem like it's any easier. That's just a different direction. So let's keep going. I'm going to take the string. You notice it goes over the top. I'm going to unclip it from the bottom. And now I'm going to put the string through the bottom around a second pulley. So now I have a pulley on the top and a pulley on the bottom. I'm going to bring the string all the way up to the top, and I'm going to clip it on a hook up here. So now I have the string going over one pulley, two pulleys, and then it's clipped in. And you'll notice there's two yellow strands here. We call those lifting strands. There's two lifting strands. The thing I'm lifting is exactly the same as it was before. It still has a weight of 10 newtons. But now I'm going to grab on and I'm going to give it a pull with my same spring scale, and we're going to see what it takes to make it go up. So here I go giving it a pull. Hey, and now I can lift it with just a little bit more than 5 newtons of force. 5 newtons of force. It takes a little bit more than just half of the force to lift it. But you may notice one other thing. When I pull down, it goes up, but it doesn't go up as far as I pull it down. So I can pull with 5 newtons of force to lift a 10 newton object, but it doesn't go as far. But it's still easier. So let's continue with this idea. Again, notice that was 2 lifting strings. If I unclip the clip again and put it back over the top, now I'm adding a third pulley, coming back down to the bottom, flipping it back on, and now you'll notice I have 1, 2, 3 lifting strings. Again, I'm going to grab on just like I did before. I'm going to grab on up here, I'm going to give it a pull, and we'll see, how much force should it take to make it lift now? Well, again, you don't have to read the scale clearly yourself, but it's right around 4 newtons. I'm still lifting 10 newtons of weight, but I only have to pull with 4 or so newtons of force now. But you'll notice it doesn't go very far at all when I pull. I have to pull an awful lot of string to get it to go very far, but I don't have to pull as hard. So again, notice how many lifting strings? 1, 2, 3. And as you can imagine, we can continue this process over and over again. Again, that's number 4. And if I want to take and add on yet another I can continue the same process. It's a little tricky with one person, but I'll try. And I can continue to add yet another pulley on the bottom. And we can build this system up until eventually we have as many with this system as 6 different pulleys. So again, now I'm coming back to the top. I'm going to clip up on the top. And now, notice 1, 2, 3, 4 strands go in between the center and the bottom. And I can feel just by pulling it's getting easier. So we're going to continue to add more and more strands. And there are 2 things about this we can measure. We can measure the output force, how hard the system pulls. Again, that was 10 newtons. And the input force, that is, how hard I need to pull down to cause the system to move. And as you've noticed, that begins to change. So Investigation 4A, the first section, is all about checking those forces, the input force and the output force.